You are listening to the Unusually Well-Informed podcast.
Welcome to the Unusually Well-Informed podcast. I'm your host, Tim Hampton. My unusually well-informed guest today is Alex Krutz. Alex is the managing director at Patriot Industrial Partners, an aerospace and defense advisory firm that focuses on manufacturing strategy and supply chain optimization. Today, Alex and I are discussing the challenges facing the aerospace industry and how companies like Boeing, Airbus, and their many suppliers are responding. We will also examine new technologies like cargo and passenger drones. Alex, welcome to the show.
Thanks, Tim. Thanks for having me.
It's my pleasure. So, Alex, you wrote an article for Flight Global titled, "Will Airbus Transform the Aerospace Industry?" In it, you describe Airbus's adoption of digital design, manufacturing, and services. Boeing is also planning substantial investments in digital manufacturing. These are both intended to integrate the concept of digital twins into aircraft production. What are the advantages of this new technology?
Well, number one, it creates collaborative, robotics and manufacturing. It creates better quality in the systems. It creates more efficiency and faster production. And really the biggest thing is less defects, right? So the more design, the more engineering we have up front to better implement work instructions on the factory floor, it makes it more efficient and better quality.
And what does that look like? So you're basically, because CAD and CAM have been around for a while, but that often is about individual parts or assemblies. This is for the whole life cycle of the vehicle, right?
Absolutely, yeah. The digital twin. There's companies like Siemens and others doing CATIA and additional modeling. But the great thing is it's this kind of emerging theme about digital thread all the way from the supply chain being able to design and manufacture into the model where there's kind of plug and play. And I'm sure we'll talk about some of the adoption, right? Out there, the A320, some of their changes, the T7 Boeing trainer. And so, but all the way, like you said, from the supply chain into production. And what's great about it, it's also into the aftermarket life cycle, right? Where it might, help some of the design engineering on the aftermarket side and services.
You point out that in the same article, you point out that Airbus is consolidating its industrial footprint. This reverses the long trend of outsourcing or spinning off activities that companies like Airbus don't view as core. What trends make this important now?
I think that for many years, everything was core to the aircraft, and that Airbus and Boeing for many years, really up until about 2004, 2005, did everything, including fuselage manufacturing, right? And that was kind of the start of the 787. And also Airbus followed shortly after with divestiture of aerostructures as non-core to their business. And that's been for about 15 years. And we're starting to see now some of that coming back into the fold, because over the last 15 years, with the structure specifically, you'll start to see cost and quality issues and other requirements that need to be met that maybe aren't or are being challenged because they're not maybe close to the core production system. So you definitely see that consolidation of the structures back into what Airbus considers as core to their airplane manufacturing.
I remember watching with awe the production of the Airbus A380, and there were like tail fins and wings being dragged all across Europe. They're assembled here, they're painted here, they're in final assembly over here. This switch to insourcing, to doing more at Airbus itself, implies a shift from distributing the work in a way that provides economic benefit all over Europe to more of an efficiency focus. How is it that they're able to do that, and what lessons can the rest of the industry learn from that?
So I think two things are happening there. Maybe it's slightly different in the sense that they're consolidating external companies that were spun off into the Airbus company. And what they're doing is consolidating that footprint. So they're optimizing their structure. So it's in the core now, not external companies they purchase from, and also starting to look at their manufacturing footprint. I think that's one thing, and that's bringing it closer to their design, development design, and production system. I think the second thing that they're doing is looking at the nucleus of suppliers and looking at strategic sourcing and supplier partnerships that are a little bit maybe closer to their manufacturing facilities, right? So they've obviously done it in Toulouse, they've done it in Mobile, Alabama, they've done it in China, and so I think that establishing those key supply chains or those hubs or clusters a little bit closer to the manufacturing facility, right, is going to be a really good thing.
So there is considerable excitement and investment around electric air taxis. What are these services going to look like, do you think, and what are the challenges they face?
There's people that are a lot smarter than me from a technical standpoint, but generally batteries are heavy and they don't produce a lot of energy that you need to offset the cost before you have to recharge it, right? So and that's in its most simplistic form. And that's one challenge, is kind of the technology of batteries. I think the other one is pilots, right? We still have to have qualified pilots flying in the air. And so when you look at the 4-seater, 6-seater, 7-seaters that are out there, you have to have a pilot, and that cost of that training and such is pretty significant, right? And so to offset both, what I would say, maybe the third thing, I'll talk about it in 3, is the infrastructure, right? Where do you charge it? Where do you land? Where do they get picked up? And how do they get serviced? So batteries, pilots, and infrastructure would be the 3 things that I would say are probably the biggest issues. And they all lead to then, how is it going to be utilized? Is it going to be fully utilized? And then what's the cost of it? And if that cost, is that acceptable to the people, to the customers that want to take that trip? So that's the 3 main important things: utilization and the cost of the ticket.
Mm-hmm. Fair enough. The other, I mean, you raised the price of the pilot. The other challenge or potential is autonomous drones, and you're seeing them in use for packages. I think you mentioned that Wing, which is a subsidiary of, I think it was Amazon, has received a license. Maybe it's a temporary or geo-fenced license to try out this technology. Do you know how that's going? Is that becoming a popular thing?
I think that it's going to become more popular, especially in probably more rural environments, right? Yeah. As you have cities, it would make sense in urban environments that it could drop it off on a porch of the 30th floor somewhere. That would be fantastic. But the minute one of those strikes something that's there's a lot to be understood about urban mobility, right? Autonomous urban mobility. So where I think it actually grows first is in the rural settings, right? From one point in Iowa to another point in Iowa, right? Or Kansas, where I'm from, right? So I'll use maybe Kansas in some of the kind of farm communities, more, kind of far-reaching communities where there's a little bit less, infrastructure in the sense of having to plan around. So I see that. And maybe into some areas of medical transport, which could be, replacing helicopters. But really, again, I see that a lot of that starting in that rural communities where it can be tested and proved out. There's also helipads out in some of these communities, smaller little airports, so that infrastructure is there. And there might be, some pilot training that, local community residents could do to satisfy. So those kind of 3 things that we talked about earlier, right? Where, you can have lower utilization, you can figure out on a smaller scale the training of pilots, and the cost is kind of offset by what you're actually doing, right? Package movement, medical, and such.
Yeah.
So that's where I really think it starts. I think it's kind of a stretch in the urban communities at this
Yeah.
point.
We won't see it in Manhattan, maybe, but I mean, I like where you're going with that, because everything starts in a niche, right? And that
Right.
medical niche is an amazing potential, right? You could
Absolutely.
have a heart move from one hospital to the other in record time.
Absolutely. Like there's so much technology and capability in that area that could save lives. So I think it has a place, and maybe 10 years down the road, might look back at this and say I was totally wrong and it's gone, ultra urban, right? But I think that the adoption in that and the regulatory and all the other issues might take a bit of time, but I think it has a niche, and it starts in smaller, more remote locations with some really fantastic uses.
Switching gears a little bit and looking around the world, you wrote an article about COMAC, which is the Commercial Aircraft Corporation of China, and they are developing a C919 narrow-body passenger jet. What challenges are COMAC facing with the development of that vehicle?
I think a couple of them. Number one, it's very closely tied to the Western supply chain, really outside of everything that's structurally oriented is built in the West. That could be anywhere in Europe, UK, US, and such. So they're very, very connected right now. And that technology is probably a generation old on, the 737NG and some of the older, platforms. But nonetheless, developing their supply chain is going to be, I think, a challenge. They'll get there. I'm sure of it. In the years to come, it might not be in the next few years, but in the years to come, they will get there to be able to develop their own technology for commercial aerospace. And I think the other issue is aftermarket and servicing the aircraft, right? That infrastructure takes many years to develop. Having parts in certain hubs, being able to keep utilization and flights. So that's a big piece of it as well. So I think supply chain and probably aftermarket support.
So, I mean, it is a fascinating world, isn't it? Because the US and China have a sometimes fraught relationship, and yet they're very closely tied commercially or industrially. And it's surprising to me that there are components that China can only get from the Western world. And the US in particular is discovering that there are parts they can only get from China as well. What are some of the I guess engines would be one, maybe avionics that China is not able to build on its own just yet?
Yeah, so engines, obviously GE and all that surrounding technology, flight software, obviously it's not hardware, but software are key. Other things that take years to develop, landing gears, nacelles around the engines, and certain types of mechanical systems, right, that need to operate. So I think those are all, really important areas that they're looking at, and they're the understanding and working with that technology is happening through joint ventures, right, with tier one and major suppliers, right, that would like to get into that market.
What type of plane would it replace in fleets in Asia? What is it? The A320 or the 737? What size of jet is this?
I think it's both. It's both. It's right in the same size of seats. Now, the only challenge is that it doesn't fly as far and it's not as efficient because of some of that older technology.
Because of the older engines, or
older engines. So fuel burn is a little bit higher nautical miles. The aircraft's a bit heavier, right, than the 737 because a lot of those design improvements that have happened over the years to reduce weight. They're just now looking at, right? And so, and again, you look at predominantly what's Chinese provided is from a supply chain is structures, right? And so when you have a metallic fuselage and wings, and that's kind of the first generation, or maybe second generation if you include their experience on ARJ, as they're kind of improving that, they maybe haven't been able to reduce the weight yet. So it's higher fuel consumption and fly shorter. But I think that that's going to be okay because for them for the coming years, because they're going to be able to utilize it for a domestic market, right? And that's really what their aim is for a domestic market.
Right. So talking about some of the challenges of where we get our parts, you've described a process, and I don't want to get confused. Maybe this is a different thing, but you've described intershoring. And to me, an example of that was SAAB, which many in North America know as a car company, but is also, they have their own fighter jets. They're an aerospace company. They've established manufacturing facilities in the US and hope to be a significant contributor to US government contracting. And this sort of reminds me of the boom in the 80s when they were Toyota and Honda and Nissan were doing what they called transplants in the US in the 80s and 90s. How significant is this trend of foreign military contractors setting up shop in the US?
It's pretty significant. Last October, I was at the Air Force Association conference, and 1/3 of all the booths and exhibitors were foreign companies, right? So there's a lot of incentives, right? The US dollar being low, right? From an investment standpoint, lots of universities and local state governments are providing for foreign businesses that want to establish a foreign-owned but U.S.-run business, or providing a lot of incentives from the government and also partnerships by university to help with study, with technology and research and development. So there's lots of bonuses, right? Lots of incentives, for companies to come and set up here. There's some things they have to do. They have to set up SSAs, which are, kind of firewalls to their foreign corporations, so that they're really U.S. run. But they're really good opportunities. It's American jobs, that's what SAAB did, and they've created a state-of-the-art, world-class factory for the T7 trainer, Boeing T7 trainer that they're partnered on with them.
That T7 has been around for a long time, hasn't it?
I think there's been variations. The T7's actually newer. There's like a T6 and a few older generations, but the T7's a bit of a newer model, and that's actually one back to your earlier conversation. That was Agile Manufacturing has been completed and should start getting to the services here soon.
You're right. I'm thinking of the T6. You're right. Yeah. It's the T6 you see in the shots with the shuttles landing, right? Like escorting them in.
Yeah, all the trainers, they go, in sequential order. But yeah, the T7's really a lot newer technology, and manufacturing methods is a really, really big part of those improvements that Boeing and SAAB have made, and it's great to have SAAB's participation on the program. They're usually a very advanced, forward-thinking company, so it's great to have their participation here in the U.S. and a part of such an important program for U.S. national defense.
Yeah, and they're a NATO ally, right? So it's a good thing. Talking about the various ways that companies work together and also provide services to a customer, one of the things you hear, particularly in military side of aerospace, is this notion of cost plus. So how does cost plus work? What are its pros and cons? And do you see it becoming more or less common with the way governments are sourcing their equipment?
I don't know if it's so much governments as it would be kind of OEMs kind of doing it. And I would say that it's probably going to be a little less prevalent for a couple of reasons. Number one is typically when there's new programs out there, that incentivizes suppliers to join that program and invest and take. But right now, there's not a whole lot of new programs. There's a few on the defense side, right, with the B-21 and but the mature ones, right, 787. 737, A320, F-35. There's, a lot of mature programs out there. So I think that there's less for, perhaps, the larger companies to wave in front of the supply chain. And I think also from lessons learned, right, that there's improvements to margins, right, that bigger companies or the government for that matter, defense contracting gets improvements as they squeeze the supply chain. But there has to be an understanding and awareness of the risk associated with that, right? We don't want to, push out qualified suppliers because they can't make money, right? And
Right.
that's so I do believe in that there, in order for us to have a healthy ecosystem, we have to have a balance where everybody has to do decent to well financially, right? If it's tilted one way or the other, then ultimately there's going to be risk in the supply chain down the line, right?
Well, that's so a couple of things. You use the term OEM, which I didn't even realize was associated with aircraft. I thought it was only cars, but that's original equipment manufacturers.
Yeah, exactly. Yeah, absolutely.
This is a tangent, but the way you described a healthy relationship with suppliers is very much the Toyota way.
Mm-hmm.
They take the view that you're not trying to get every penny out of your supplier, that it's a long-term relationship, or you're not going to get quality parts after a while.
Absolutely.
It does remind me of that approach.
There's a lot to be said about the Toyota way, right? It's been a fantastic method and methodology for many years. And I think, probably the aerospace industry could maybe, kind of reflect on that a little bit. I know that there's this healthy tension between aerospace and automotive, right? For a variety of reasons, but there's a lot of things, the Toyota production system, and the Toyota way that are I think really good methods that we just need to continue to look at and see how they're applicable to the aerospace industry.
Mm-hmm. When you say healthy tension, are you referring to sort of the cultural tension between that's how they do it and that's how we do it, or are you referring to Honda trying to make its own jets?
No, not Honda. Its own jets, but more of they do it like this, we do it like that, right?
And you also do it in batches of 100, which is very different.
Which is very different, right? And the quality requirements are a little bit more stringent, right? Versus the high volume, Yeah. So there's a bit of differences, but at the end of the day, it's manufacturing, right? High quality on time product to get customer service. So I think that there's some very common themes that can and are shared between the two of how to conduct business.
One of the interesting things you talk about when it comes to consolidation, this idea that the pendulum swings, right? One day we're just going to focus on what we do best and we're going to outsource everything else. And then the next day we're going to start bringing things back into the core. One of the things affecting that is that OEMs tend to get better interest rates than suppliers. I thought that was an interesting insight that may affect the fact that during lean times, the OEMs can bulk up. Is that something you're seeing going on?
They can bulk up, but when they bulk up, it's all about production rates. If they have higher production rates, they can absorb their overhead costs across more units, right? But when you have lower production rates, having more internal manufacturing or vertically integrated manufacturing can be a challenge for big companies, whether it's aircraft manufacturers or large tier ones or twos. So there's kind of that balance in what we kind of call the make buy, right? What are we making in house and what do we buy externally, right? And so it as kind of programs go up and down and new ones come in, that make buy strategy and analysis is always really important to be done, on a 1 year, 3 year, 5 year outlook to see where it's going, because you can't just, the pendulum does swing, but it's slow, right? It's not usually, unless it's like something's, crazy out of whack or, there's been an emergency of some type, usually, insourcing or outsourcing takes a bit of time to go complete.
I'm going a bit back and forth, but you keep making me curious about other things. So one of the things going on with the passenger drone market is, you were talking about some tension between aerospace and automotive, there's also a tension now between Silicon Valley and aerospace. Silicon Valley is kind of invading in its own way in aerospace. I mean, SpaceX is a huge example, but also in the drone space, you're seeing automotive companies out of Silicon Valley. How do you see the industry shaking out over the next decade?
So there's a lot of capital going in, right? A lot of capital going in by Silicon Valley and investors, be it through, companies that are revenue generating and producing product. Some are going public, some are going through the SPAC process, right? Special purpose acquisition corporations, right? Which, a lot of money joins with a non-revenue business for the potential future. So I see that as the main support right now, that there's an influx of cash into the industry for new technologies, but a lot of it's centered around eVTOL. It's centered around some defense products, and maybe a little bit about software and services, right? Maybe less in the R&D of traditional aerospace or defense manufacturing. So I think it's a good thing, but I think we also have to recognize that that could a bubble be developing, right? With a lot of money going into non-revenue based companies. Now, again, I'm all about technology and forward thinking, but at a certain point, it might become too much, right? And there might be, the aspirations might be too high, or the market might not be big enough, right? Like you said earlier, it might be niche, right? And sometimes niche markets don't have a lot of volume or opportunity at first, and can those businesses survive that cyclical growth into a new segment of product?
Right. So you are known as the factory doctor. And what are aerospace and defense factories' common ailments, doctor, and what is the prescription?
A lot of it starts with like manufacturing 101 type stuff, right? That's one of the first places I start with companies is, are you ordering your material on time? How are you sourcing your materials at long lead time, cheaper mill runs versus short distribution? Are you starting on time, right? Are you getting it there? Do you have your planning, your engineering all completed? And are you starting so the factory has enough time to complete it? Have we looked at optimizing some processes? Like, what products do you put together, what I call nesting out in the factory, right? So that way you can optimize your setups and your machines, your spindle times, your operators. And how do you do like demand planning and forecasting with your customers? There's even other things, contract review, like what are you accepting and working with your customers on? How do you flow down their requirements, and looking at kind of quality as built in versus inspected. So these are all things that I look at, scheduling and, shipment logistics. What type of things are we working on? So a lot of those are basic things that a lot of businesses just don't do well or don't get right. And that's what I go in and help companies with is first, let's start with the basics before you can get into advanced manufacturing and digital twins, digital thread, Industry 4.0. A lot of those things are really great, but first of all, you have to start with a good foundation. And so that's a lot of what I do.
So that's really interesting. I'd like to explore that a little bit. So, it's a common thing in any tech field that people think they can just buy the program and everything's going to get better. But it may not be true that you buy the program and everything gets better. But if you buy the program, does it help you get through the phases of industry 1, 2, and 3? Or is it just too much and you really do need to go through that gradual progression?
Programs, systems, they're all tools to help you get from point A to point B, right? And so companies need to know where they're at right now. And that's the true, what we call a Kaizen process. What's your current state, right? Where are you at right now? And what's your future state? Where do you want to go? And how are you going to get there, right? And so there's the systems are a tool to help you get there. They're not the main focus, if you will. And a lot of times companies will say, hey, this is going to solve our problem. And that's not really the case, right? Because then you have other soft issues when you talk about employee training, organizational culture, how, leadership, right? How you, incentivize teams. So those are all some of the softer and very important things, but systems are a tool. They're not the ends, if you will.
Mm-hmm. So the aerospace industry was severely impacted by the pandemic. You have written that and this is in quotes now, the first aerospace supply chain pain point will likely be within the airplane engine segment, which historically has issues during demand increases and past super cycle ramp ups, end quote. So why is that, and what can OEMs do about it?
I think there's kind of two main things that I see there. And it's very common to hear in earnings from larger companies that forgings and castings, it's a black art. It's very hard to do, right? Whether it's pouring or forging, you have to get certain grain structures. There is high level of scrap or defects, not because it's just byproduct of how the product is built and getting the requirements that are needed for engines. And so those are sometimes 12, 15 months in length. And so they have to be staffed up right. They have to have all the raw materials in. They have to be working. And sometimes they have to make two to produce one, right? And so you have to ramp up. So forgings and castings has always been a challenge part of the industry. I think the second part is transfers of work, right? So the engine companies for a long time have had a tail of suppliers, right? So they have 80% of their suppliers are kind of strategic suppliers, but then this other 20% is what they would typically call the tail, that are smaller, kind of mom and pop, tier 3, tier 4 businesses that just over time they picked up another supplier, picked up another. And if the health of those are not doing well, or they want to consolidate those, from a transfer of work of component here to component there, there's going to be some challenge within that as well, right? So those are the two main things that I see, the kind of the very small suppliers that they might be moving, and then the forgings and castings within the engines.
There's a lot going on in the automotive industry as well, thanks to parts constraints. Are there any parts in common between the challenges of automotive and aerospace, or is it very different parts suppliers that you rely on?
There's some commonality in aluminums in how they're bent, at forming shops and such. But traditionally, the composites manufacturing is a little bit different with aerospace because of autoclaves and some of the quality requirements, whether it's pressure and heat that have to be tested in for or burn, that aerospace has to test in that quality that necessarily I don't think those same requirements are. So there might be some similar methods, but that's how automotive can yield higher rates because of I'll call it, fewer requirements that need to be met on the product, right?
Yeah. Well, and they can be heavier and so have a better margin of safety too.
Absolutely.
Yeah. Do you see permanent impacts resulting from the supply shortages? Like, is this going to change the way the industry works forever, or is it just a blip?
I think it's probably somewhere in between. There's been shortages and other, major events in the past that have taken a few years. I think it's going to take a few years to sort through, some of the business failures, some of the logistics bottlenecks, some of the costing and price issues, availability of materials, right? So I think it'll take a couple of years. So I wouldn't say a blip, but are we talking about some of these issues 5 years from now? I don't think so. But for the next 18 to 36 months, absolutely.
So I have to ask you, just for personal interest, it strikes me that between all the destruction that's happened in the airline industry, I mean, the demand destruction anyway, and all the pent up demand, and the fact that we haven't been making planes as much as we would normally, It strikes me that in a couple of years, plane tickets are going to be very expensive. Is that true, or do you see something that makes that not true?
I think that we've seen some increase, increase in tickets right now. I think it comes back down because right before the pandemic, I don't know exactly, but I would say for probably a year, a couple of years, airlines started to become profitable after many years of not being profitable, right? So I think that one of the big things that was a big changing factor was a system, right? Scheduling systems, and how to optimize seats. And if you probably recall, 10 or 15 years ago, you'd always have a middle seat open and it would be kind of 3/4 full. Airlines have gotten really, really good at optimizing the flights, when to put on a new flight because they have enough demand to be able to fill it, right? So I think as they continue to bring out parked airplanes and utilization of aircraft and more flights start to happen, I think that we're going to have an increase in profitability with the airlines back to where they were. It's probably about 2 or 3 years out to really, like I said, really kind of work through some of these things. But I don't see that high tickets will be a long-term thing. Now, the only caveat is if oil goes to $100 a barrel, all bets off the table, everything's going to be expensive, right? Yes. So there could be some, macroeconomic factors that I'm not considering in the statement, but if everything is as it is kind of today and we progressively are getting better in this industry, I see that ticket prices should stay the same, if not come down a little bit.
Another sort of idle curiosity question. I know this is a bit outside your field, but I understood that one of the reasons flights were getting cheaper was because there was a rethink on the hub and spoke model. Like it used to be, you take a giant aircraft from one huge airport to another, and then you have to take 2 commuter flights to the giant airports. Mm-hmm. And now you can do more direct because of the planes like the 737, right? Is that a change, or am I misinterpreting that?
Yeah, absolutely. And also the A321, which Neo and their longest variant, which is called XLR, extended long range. It's basically on the bottom end of what Boeing used to do with the 757, right? Mm-hmm. And it's what they call the middle market, and there's kind of a hole in it right now. And the A321 XLR is filling that for the most part. The 787-10, right, is slightly smaller and lower range than that. But you're absolutely right. Those 2 aircraft are going to be used as the kind of point to point versus a hub type system. I think that also from a few years back, planes like the 787 and A350, for that matter, Boeing 787 and Airbus A350 have also created point to point longer routes that were maybe once upon a time done by the 777, 747, or A380. Mm-hmm. So those longer point to point are kind of growing as well. So that's definitely going to be a trend that will continue.
So one of the consultations you have done was with Spirit Aero, a Boeing supplier. Since then, the company has faced a sudden drop in demand due to the grounding of the 737 MAX and the pandemic, of course. So you made some observations about how they're taking advantage of the lull. What are they doing to prepare for the future?
So they really focused in on quality, right? Cleaning up their business, foreign object debris or FOD awareness, a customer-centric approach, right? Really working with your customers on their product. So that's on the quality side. Digital, they've really tied in, new warehousing where they have pick systems to get parts to the factory more efficiently through some robotics. They have digital threads into the supply chain. That's going to be a good thing. And then a lot has happened on the manufacturing floor, advanced manufacturing, where they have manufacturing engineering planning that's very visual, that shows work instructions to the operators. There's a little bit of, which is really cool, some digital reality or augmented reality where they can put on some type of visors and see how the production should be going. I think that's in its kind of inception, but it's really kind of industry leading to say, if there's a newer employee, how can they go and see what it should look like kind of through the process? and being able to see what jobs need to be worked on, a lot of visual factories. So they've been doing a lot of really good things that I think larger companies should take notice of.
There's a couple of threads in there I'd like to pull on. One is, you know, you are interested in and probably a proponent of lean manufacturing. And one of the things that comes out of Toyota production system is always just go to the Gemba, right? And here we have a situation where you might go to the Gemba, but you're wearing goggles. And that could really shrink the distance between suppliers and OEMs.
Absolutely. I don't know the augmented reality and the goggles in that type of system, how that'll be for the suppliers to the OEMs or tier ones like Spirit, but I definitely could see it in the factory, right, where it gives visual work instructions, right? That's a big part of the future. And that's back to the point we talked about with systems, right? If you have good manufacturing methods, right, stability in your production process, and then you add this into it, it can really enhance your production capabilities. And so I think the first place is really inside the factory, improving when you're putting all the components together and creating an assembly is going to be a really big opportunity for these tier ones like Spirit and utilizing those tools.
One area where manufacturing often suffers is the lack of communication between silos. You know, you've got your engine team and your, I don't know, I'm making stuff up, your fuselage team and your avionics team. And how can aerospace companies increase collaboration between teams?
So can you say that maybe a little bit differently?
So one of the I'm thinking of, I'll come back to automotive because that's, I'm a little more familiar. I've never worked in it, but I've studied it.
Yep.
So you have your engine team and you have your transmission team, and they have a stable interface between the two, and that means they can work separately without consulting one another. But sometimes it's at that interface that you can make the best improvements.
Yeah.
And so how do you encourage that kind of collaboration between teams in aerospace?
I'm getting really technical here, but in aerospace, we call it IPTs, or integrated product teams, right? So as airplanes are developed, technologies are improved and implemented, manufacturing and into the supply chain, those integrated product teams or program management structures will put multiple different business segments together to make sure that they're designing very safe, very efficient, good cost, good quality, all these things into their systems together. So those integrated product teams are less relevant at the smaller suppliers as they are at the larger tier one, companies or those airplane manufacturers where they have to bring these big systems together. And those IPTs are really important. And that's been, I think, one of the things in aerospace that's done well for many years is that collaboration amongst those different teams.
Thanks. That makes a lot of sense. And I just want to geek out a little bit because I have this aerospace manufacturing expert with me. So this, talking about proponents of agile manufacturing. So agile, the way I understand it, it really looks at continuous improvement, right? That not just to the manufacturing, but to the product itself. So it's not just do it. And so Agile wants to say, let's do it and figure it out. And Lean wants to say, let's figure it out and then do it. How can aerospace companies capture the advantages of both the experimentation and the planning? Do you see any changes in the way companies are thinking about how to do that?
Yeah, what's dangerous is trying to make changes on an unstable or unmature system, right? And so I'm always an advocate of have a good infrastructure, have a good stability to be able to build upon, right? And then continuous improvement or the tinkering or changing really has benefits, right? But I've seen kind of too often that the infrastructure or the base is not well established, and then teams or people, companies try to change. And sometimes that creates additional variability or defects or inefficiencies in the process. So I'm a big believer of establish your infrastructure and foundation and then change away, right?
Yeah, and I guess one of the things that is more challenging in aerospace than in automotive they say every third car coming off the assembly line at Tesla is different than the one before. You can't do that with an aircraft because it's a certified type, right? So people in the field have to be able to fix it. People have to be able to fly it. So I assume there's a very low cadence of changes from one aircraft type to another. Is that true?
Yeah, absolutely. There's a lot of regulatory compliance in how and when changes can be made. So when it's approved through its design and development and then passed through, they're very strict requirements. There are some companies that have design authority or can make changes through their engineering departments through delegated authority. But most changes have to be approved kind of up the line to the aircraft OEM, and many of them through to the regulatory authorities. So there's a high consistency from plane to plane because of the nature of this is what's certified, so this is what has to fly, right?
So this has been terrific. I have one last question. I hope it's a fun one for you. I've heard the expression that if it looks right, it flies right. So my question to you is, what is the most beautiful plane in the air today?
The most beautiful plane in the air. I would probably say the 787, right? For a couple of reasons. Boeing 787. One, the wing structure, especially when it gets in air, it starts to bend. The ability of those wings are fantastic engineering. The flying experience is great, right? The dimming windows, air circulation, cabin pressurization, where you don't get the
ear pop.
The ear pop or the jet lag. And it's a beautiful airplane, right? And the A350 1000-1000 for Airbus right behind it is almost on par in my mind, right? But that's a beautiful plane. It's the 787. Now there's lots of different other things to talk about with it, but when you talk about the flying experience, beauty of the plane, it was a game changer for our industry for sure.
It definitely has sort of a graceful. That's the one with the curved wingtips, right?
Yep, absolutely.
Yeah. That is a beautiful plane. Good choice, Alex. Thank you so much for being on the show.
All right, thanks, Tim. I really appreciate. Thanks for having me on.
My guest today was Alex Krutz. A link to Alex's LinkedIn profile will be in the show notes. My name is Tim Hampton, and you can reach me at tim@unusuallywellinformed.com.
Thank you for listening to the Unusually Well-Informed podcast.
The opinions expressed by the host and guests on the Unusually Well-Informed podcast are their own and do not reflect that of their employer or any other affiliation.